Good afternoon, my YouTube viewers. It's Crystal here. I'm just here this afternoon because I want to do a code review on how to use the self-training classifier, which is with sklearn semi-supervised model. You have three models in sklearn that deal with semi-supervision, which are self-training classifier, label propagation, and label spreading. And what we're going to be talking about in this code review is the self-training classifier. And in order to demonstrate the self-training classifier, we're going to be using sklearn's iris toy dataset. So I've created this program in Google Colab, which is a free online Jupyter notebook. It's a really good platform to use to make your programs. It's good for data science applications, but it's not good for every application because it doesn't do animations. If you want to do something that's animated, then you would need to use Replit or another interpreter. So one of the bad things about Google Colab is it doesn't have an undo function, so you have to be careful not to delete or overwrite your code. But if you do accidentally do that, you might be able to come here into the save history of the file, and you might be able to get the code back that way. But it doesn't always happen. I've had instances where I was working on another computer and it didn't save properly, and so I lost the code and I had to completely redo it, and that wasn't very nice. So after we create our program, we're going to import our libraries. So we're going to import NumPy SNP, which is for numerical computations. We're going to import Pandas SPD, which creates and manipulates data frames and does data processing. We're going to import matplotlib.pyplot SPLT, which is going to carry out our graphics. And we're going to import warnings because I don't want to have to see the warnings, and I don't want to have to see the warnings. So that's what we're going to do. After we have imported our libraries, we're going to use sklearn's load iris dataset. So data equals load iris, and then as frame equals true. So we're going to be using the as frame. We're going to convert it to a data frame, and x equals data.data. So df equals x, df target equals data.target, df equals df sample.sample, frac equals 1, random equals 42. In that line of code, what we're doing is we're shuffling the data set, and frac equals 1, so that's fraction equals 100%. df copy equals df.copy, y orig equals df underscore copy target, and df. So you got your what you got is you got a shuffled data set, and the reason why you shuffle it is because there's the hope that your predictions will come out better if the data set is shuffled. So if it's not shuffled, then you have a third of the rows are zeros, a third of the rows are ones, and a third of the rows are twos. And I don't think that bodes very well for making predictions. 1 second. That was just a junk call. That was just that. I also got a phone call. Also received another bronze medal on my Kaggle. I've never received a silver medal, but I have received a bronze medal. So getting back to the code review, what we do is we shuffle it, because if we didn't shuffle it, it would be zeros, ones, and twos, and that wouldn't be very good for making predictions. So we shuffled it, and then all the rows are jumbled together. That's why we shuffle it. And so we're going to do a value count on Y ridge, and that's going to give you 50 rows of 0, 1s, and 2s. And now what we're going to do is we're going to put it on a graph so you can see what the data points look like. And so you can see that all of the data points are scattered all over the place, and you've got 0, 1s, and 2s in the data points. And that's a 2D graph. And now we're going to look at a 3D graph so you can see how your data points are in the 3D graph, and you can see where they are in memory, which is really fascinating if you think about it. Now what we're going to do is we're going to insert the unlabeled data into the data set. So RNG equals NP random.random state 42, random UNL, which means unlabeled, equals RNG rand df target dot shape 0 is less than 0.6. So that means that 0.6 of the columns are going to be unlabeled. df target random UNL equals -1. So every row that's unlabeled is going to be given -1. And because that's what they want to do in sklearn, they want sklearn to have every row that's unlabeled to be -1. So you can see a decaf. So you can see now we've got lots of -1s in there. And the reason why if you see a -1, it means that for all practical purposes, that row or example of data is unlabeled. So we look at Y ridge again, and you've got 50, 50, 50, 0, 1, 2. And the reason why I'm looking at Y ridge, because for some reason, whenever I was manipulating the code, if I didn't make a copy of the data frame and I didn't make a copy of Y ridge, then what would happen was Y ridge would be the same values as the DF target values, which is not what I wanted, because you have to have the Y ridge so you can go back and check your predictions. And so that's why I had to make a copy of the data frame, and your Y ridge is the target of the copy data frame. And so now, after we checked our Y ridge and we know it's 50, 50, 50, we look at df.target value counts. So you've got 95 as -1, 22 is 2, 18 is 0, and 15 as 1. So you can see 60% of the rows are a -1. And so that means for all practical purposes, they're unlabeled. And now what we're going to do is we're going to define our X and our Y. So your Y is your last column of the data frame, which is df.ifoc square brackets colon comma -1 square brackets. And your X is all of the columns except for the last column. And so that's X equals df.ifoc square brackets colon comma colon -1. So that means it's giving you all of the rows. The first column is all of the rows. The second column is all of the columns except for the last one. And then we check our shape. So our shape in X is 150 rows by 4 columns, and our shape of Y is 150 rows by 1 column. It's not even 1 column, but it is 1 column. Okay, now what we're going to do is we're going to define our model, and in this particular instance we're going to be using sklearn's self-training classifier, which is a semi-supervised classifier, and then we're also going to be using sklearn's support vector classifier, which is SVC. So CLF equals SVC brackets probability equals true, gamma equals auto. So you can use any self-training classifier that will let you check your probability, will let you do predict proba. And we'll just do a quick break here and look at self-training classifier on sklearn. So you've got your self-training classifier. It tells you a little bit of what it is. You've got your base estimator and estimator object implementing fit and predict proba. So if the estimator has a predict proba in it, you can use it. So support vector classifier has a predict proba, so you can use it. It says a threshold, and then you can change the threshold if you want. Criterion, K-best, max iter, and verbose. So it says default is 10. Maximum number of iterations allowed should be greater than or equal to 0. If it is none, the classifier will continue to predict labels until no pseudo labels are added or unlabeled samples have been labeled. So that's good. We can do max iter is none. Let's try to do that. See if that includes, well, we've got 99% accuracy. Let's just see what we've got here. Max iter equals none. So what we'll do is we'll go through the code and then we'll run it up to none and see what happens to our accuracy if we change the max iter. And then we're going to fit X and Y. And the reason why we fit X and Y into the model is because in this particular instance we didn't use X train, Y train. I know we have used X train, Y train in the past, but in this particular one we're not going to use it. So you've got your CLF, which is SVC, probability equals true, and gamma equals auto. You can use SVC because it has a predict proba method in it. And then ST model means self-training model. A self-training classifier. Base estimator equals CLF, which your CLF is your SVC. Max iter, I changed that to none, and we're going to fit X and Y. YPRED equals ST model predict X, and this is your YPRED. So you've got 0, 1s, and 2s in there, which is what you want to see. You don't want to see any negative 1s. So we check our accuracy, and this is a function that I made, and your accuracy is 99.3%. And then we check our confusion matrix, and your confusion matrix has everything correct except 1. So you got 0, 1, and 2, and on the 1s, one of them were not correct. And then we check our true labels against our labels, and you can see where you've got your true labels against your labels, and you can compare that. But what we're going to do now, just to see if our accuracy has improved if we use max iter, we're going to rerun it. And see what happens, see if our accuracy goes up. Nope, it didn't change the accuracy. but we'll go ahead and keep it as none, even though the accuracy was not improved. So that's it. That's the code that you can use for your self-training classifier. And I'm going to be making a blog post on this as well. So I'm going to go ahead and conclude this video since we said everything we can say about this particular piece of code. I would like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. Thank you very much for watching this video. I look forward to doing more videos, code reviews for you in the future.